Okay, we were working on number 11 on page 3 of the practice test. We found the vertex at the end of the last video. We said it's always the opposite of what's in parentheses, comma, what's outside. And we can do that fast, easy way because remember this is in vertex form. Axis of symmetry is a vertical line, so it's always x equals, and you pull the x from the vertex. And then we found our point, 3, 8. We drew in the axis, or we're drawing it in as the video ended, but it not only says sketch, it also says label. So that's why I put the x equals 3 there. We've got the vertex over there, so now we're ready for X-intercepts. So we did a lot of work on X-intercepts in our notes. X-intercepts mean make y 0. And as hopefully you all know, f of x is your y, so you turn that into 0. And you have negative 2 times x minus 3 squared plus 8. And remember, this parabola is going to come upside down because the leading coefficient's negative. So I see this is negative, so I'm going to bring it over to make it positive. So add this quantity here to both sides. So plus 2x minus 3 squared. That way we'll have just positive numbers to work with. So 2 times x minus 3 squared equals, this is going to cancel, and so we just have 8. So all we did was change the sign, bring it over to the other side. I think I'm going to make this smaller just so we have more room and I don't go off the camera, hopefully, or off the screen. So it was negative on the right, so I moved it over to the left, and that quantity just became the same thing but positive, and then we have the 8. So just move that over, and I know this one's on the final too, so this is a good one to make sure you know. And this, you can tell, is going to be a square root property. In order to do the square root property, remember your squared quantity has to be isolated, and it's not. There's a number outside, so we do the opposite to get rid of it. Since this is multiplication, we divide by 2, and we get x minus 3 quantity squared equals 4. So this is just like the problems we did on the front page of this practice test. So we have a perfect square, or a squared quantity equals a number. So we take the square root of both sides. And here's the next one you'll miss if you forget to plus or minus. So that's going to turn into, this cancels, x minus 3 equals plus or minus. And the reason, again, I have to do plus or minus anytime I square root both sides, not square both sides, square root both sides of an equation, I have to add in the plus or minus because this guarantees me 2 solutions. You forget the plus or minus, you're only going to have 1. And so plus or minus 2. And then we did this problem on the front page. When it comes out like this and they're like terms, you write your 2 scenarios. X minus 3 equals positive 2, or x minus 3 equals negative 2. Solve both of those and you will have your x-intercepts. So x equals 5. And up here we wrote y is 0. And remember, intercepts are always written as points. So x is 5, y is 0. There's my first one. So we can draw that in, which would be right here. And then solve this one. Add 3, we get x equals 1. So there's our second one. And remember, parabolas are always symmetric. So anytime you draw in points, see if they're symmetric. This one's 2 to the left. 2 to the right. This one's 2 to the left. So looking good. So that tells me that I did the problem correctly. When I plot my points and they come out symmetric. If you plot them and they don't, that means you made a mistake somewhere. So it could be a mistake finding the vertex. It could be a mistake finding the intercepts. So let's go up here and write our two answers, 5, 0, and 1, 0. Y-intercept. I think I'm going to switch colors here since I'm kind of skating on the edge. So Y-intercept is when we make X 0. We always make the other letter 0 on our intercepts. So I go up to this original equation, and everywhere I see an X, once, twice, I'm going to fill in 0. So f of 0 equals negative 2 parentheses 0 minus 3 squared plus 8. And then my advice to you would be plug that into your calculator. I know it's probably something you can do in your head, but just to be safe, because it's a little messy. So to plug it in the calculator, we type negative 2 parentheses 0 minus 3, close your parentheses, hit your x squared, and then add 8. And that leaves us with negative 10. And so that means my y-intercept is 0, negative 10. Because remember, this is my x, this is my y. So I can go up here and write 0, negative 10. So now we're ready to plot that point. So 0, negative 10 is right here. I see I didn't make my axis of symmetry quite long enough, so let's bring it down a little bit further. And remember how I said you need 5 points. So how do you get the 5th point? You reflect the y-intercept. So this is 1, 2, 3 to the left. So then go 1, 2, 3 to the right. And you can see 3 boxes looking good. So now we're ready to graph. Let's go ahead and draw our graph. So make sure it's rounded, arrows on both ends. Remember, these are not V's. V's are absolute value graphs, which you'll learn about in the next class. And this one is a very thin parabola because remember how the number in front makes it skinny or fat? So a fraction in front makes it a wide parabola. Number in front besides 1 makes it thinner, a whole number. So if it was 2 or 3 or 4, it's going to be a thinner parabola because it's going up more quickly. We call that a vertical stretch. Back in, that might have been, 7.3, I believe, was when we talked about vertical stretches and shifts and mother functions and all that. So our graph is complete. We have 5 points. We have the vertex marked. Now we can answer the last 2 questions. So domain and range. Domain, remember we said every parabola goes left forever and right forever. So even upside down, they go left forever and right forever. That's why I always say don't forget the arrows. So this parabola is just going to keep getting wider and wider, so it'll eventually encompass every x. So the domain of every vertical parabola is negative infinity to positive infinity. The range, you have to do your pencil roll to get it. So we start with the bottom, because we always go bottom to top. I see there's arrows. The arrows tell me it goes down forever, so that means the lowest y value is negative infinity. And the highest y value, and this is why we always mark our vertex, our highest y value is 8. And since it's a point on the graph, remember it gets a bracket just like we did in our notes earlier. So there is the domain and range. Every vertical parabola has that for a domain. Then you have to do the range from bottom to top. Lowest y value, highest y value. Okay, let's go ahead and do this next one. So this one we can't tell by looking what the vertex is, so we have to use that special little formula we learned. You guys remember it's from the quadratic formula. So here's the quadratic formula from our first page. So this is the discriminant. This is how we find the x of the vertex. So once you remember this formula, you get 3 formulas from it. The whole thing's a quadratic. When you're finding the discriminant, it's that piece. When you're finding the x of the vertex, it's the opposite of b over 2a. So it gives us 3 different things. So x equals opposite of b over 2a. So we look up at our equation. The opposite of b would be positive 2 over 2 times 1. A is 1. So 2 over 2 is just 1. So we know our vertex is 1 comma something. Now we have to find the y, and remember, once you get the x, just everywhere you see an x, plug in 1. So f of 1 is 1 squared minus 2 times 1 minus 8. You can either plug that in the calculator or do it in your head. 1 minus 2 is negative 1 minus 8 is negative 9. So now we can plug in that, and we can write this. So x is 1, y is negative 9. Okay, so let's go ahead and put that on the graph. So 1, negative 9 would be right here. This parabola has a leading coefficient that's positive, so we know that means it's going to cup upward. And let's go ahead and draw on our axis of symmetry. Let's write it. So axis of symmetry, oops, I forgot to label this as the vertex. Axis of symmetry is always x equals whatever the x is. So now let's go ahead and sketch in our axis of symmetry, which is x equals 1. And remember, the directions say sketch and label. So read this right here, sketch and label. So we sketched it. Labeling it would be giving it its name, x equals 1. Okay, next we have the x-intercepts. So x-intercepts, remember, mean make y 0. Bring this up a little bit. Well, I want to write this, see the equation too, so we're going to have to make it small again. Make y equals 0, so our f of x, remember, is our y. That takes the place of y. It's just function notation, so make that 0. So we get 0 equals x squared minus 2x minus 8. So this is from chapter 4. When you have a quadratic set equal to 0, that means you factor. Factors of 8 that subtract to 2 are 4 and 2. Largest one negative, so x minus 4, x plus 2. And you can check it. Negative 4x plus 2x is negative 2x, and negative 4 times 2 is negative 8. So if a times b equals 0, either a is 0 or b is 0. And so add 4, we get x equals 4. Subtract 2, we get x equals negative 2. So our two x-intercepts are 4, 0 and negative 2, 0. So we can go ahead and put those up here. And we can draw them on the graph. So 4, 0. Whoops, we're doing green. 4, 0 and negative 2, 0. Check to make sure they're symmetric. 1, 2, 3 to the right. 1, 2, 3 to the left. That's our little intermediate check to make sure everything's on track. Okay, and last we have to find the y-intercept, remember, and then reflect it. So the y-intercept is when we make x 0. So again, go up to your original equation. I see 1, 2, 3 x's, so make them all